I once heard someone describe BizTalk Server by saying that it provides transformation and transportation. It's true to say that it provides a whole lot more than that, and we'll discover that as the course progresses. But talking about transformation and transportation are probably not a bad place to start. So having said that, we explored BizTalk schemas in Module 2, and then we saw in Module 3 that once we have described our message using schemas, we can take advantage of BizTalk maps to implement transformations. In this module, we're going to focus on BizTalk's ability to transport messages. And specifically, we're going to look at the capabilities that BizTalk provides to route those messages. Rather than just blast every message to every destination system, BizTalk allows us to specify filters, and that gives us some control over which messages go to each system. So let's dig in and see how we can use BizTalk to route messages. BizTalk's message routing capabilities are built on a publish-subscribe architecture, and we're going to start off by taking a look at that in detail. We're going to talk about some of the configuration objects that we'll encounter as we start making use of the messaging architecture. Later on in Lesson 2, we'll walk through the steps that are required to set up a message routing solution in the BizTalk runtime environment. I'll show you the configuration settings that you need to apply and how to get that application up and running. And then at the end of the module, we'll take a look back and we'll review some of the tracking information that BizTalk collected while messages were passing through our application. It only makes sense to start off this lesson by talking about BizTalk's publish-subscribe architecture. After all, it serves as the very core of its message routing capability. So we'll spend a little bit of time talking about what that means and exploring it in more depth. After that, I'll go over some of the terminology and concepts that you will encounter as you start creating BizTalk messaging solutions. And then I'll end the lesson with a demonstration, and I'll show you how we can configure a schema to instruct BizTalk to extract particular fields from a message. And then as the module progresses, we'll use those values to implement our message routing application. Okay, so what exactly do we mean when we talk about a publish-subscribe architecture? Well, probably the easiest way to understand it is to see it work. And so that's what this animation will simulate. We'll step through a sequence that a message follows as it passes through a simple BizTalk application. At the center of the screen, you can see the BizTalk message database, also known as the message box. All of the other components on the screen are going to communicate with each other through the BizTalk message box. Now, before our application is ready to receive messages, we need to set up some subscribers. So the orchestration and the send port will each register a subscription with the message box. And that subscription is going to indicate which types of messages it is interested in. When a message is published to the BizTalk message box, not only is the content of the message published, but a collection of properties that describe the message are published along with it. And that set of properties is known as the message context. So these subscriptions are created in terms of message context properties. When a message is published to the BizTalk message box, and the context properties of that message match some subscription, BizTalk will automatically send a copy of the message to that subscriber. So once these subscriptions are established, our application is ready to start receiving messages. When a message comes in, the receive adapter and receive pipeline are going to work together to process that message and publish it into the message box. Once that message is published in the message box, BizTalk is going to search for subscribers. So it is going to examine the context properties of that message, and it is going to try to match those with each of the subscriptions that have been registered. When the message box has found all of the matching subscribers, it will send each of them a copy of the message. And each of those message instances would be unique. The various subscribers would not be sharing a copy of a message. So, once our orchestration has had a chance to consume that message and process it, somewhere along the line, it will publish a new message back to the message box. Once again, BizTalk is going to try to find a match between the context properties of that message and one or more subscriptions that have been registered. Now, anytime it makes this check, if it does not find a subscriber, the message will remain in the message box, but it will be suspended. And the message will remain there until it is either resumed or terminated. We wouldn't be able to resume it, of course, until we had a matching subscriber for that message. Since our orchestration has published a message, and that's exactly what our send port is interested in, BizTalk will find a match between the subscription and that message, and so it will deliver that message to the send port. And the process is complete. So our receive location acted as a publisher, the send port acted as a subscriber, and the orchestration played both roles. It was both a subscriber and a publisher. Well, what benefit is all this? Well, for one thing, as we add new components to our system, if we think about our design carefully, we can minimize the dependencies that they have upon one another. If we need to start sending these messages to more than one location, for example, we can simply add a new send port to our application, and there are no other changes required. We simply have a new send port that has registered a subscription with the message box. There's no impact to the orchestration, and there is no impact to the other send ports. One of the other benefits is the scalability. It's entirely possible that our receive location is running on one server in our BizTalk group, and the orchestration could be configured to run on one or more other servers in the group, and the send port could be configured to run on yet another server. But since they're all communicating through the message box, we can arrange and rearrange the assignments of components to particular hardware by simply making configuration changes in BizTalk. So it's true that we do pay a price in terms of latency, since everything has to be written to the message box. On the other hand, in the overall picture, we receive some pretty nice benefits. So it might look kind of complicated when you try to digest it all at once, but if you break it down into pieces, a publish-subscribe architecture is actually pretty straightforward. And it's good to keep all of this in mind as we start creating a message routing application, because if something goes wrong, there's a good possibility that the problem lies in a subscription that we have created, or the problem lies in the message that we have published. We may have set something up incorrectly so that the message does not have the context properties that we expect when it is published to the message box. So what exactly is the BizTalk message box database? Well, it's one of the things that gets created for you when you configure BizTalk for the first time. You can easily see what it looks like by opening it up in SQL Server Management Studio, a whole series of tables and stored procedures. And its main purpose, of course, is to store messages and their context properties. And it stores subscription information. And it also stores orchestration information. So to some degree, it serves as a message queue. It holds on to data, and then it delivers it to components for processing. And it's collecting tracking information as well. As time goes on, the message box database can grow large, so there is a SQL agent job that runs periodically to move tracking data over to the tracking database and then purge old message content. Now, BizTalk even allows you to create more than one message box database for a BizTalk group to help distribute the load. If you do that, by the way, once you create a second message box database, all interaction with those databases now needs to be coordinated as a distributed transaction using the MSDTC service, the Distributed Transaction Coordinator. And so that can actually slow things down. So you'll find that you actually won't gain any performance until you add a third message box database. And so by making use of the BizTalk Administration Console, administrators can manage and maintain these message box databases. And I mentioned that there is a SQL agent job that purges and archives tracking information. There is also a SQL agent job that allows you to perform a backup of the message box database. All right, so that's all well and good, but what can we actually do with this stuff? How can we actually deliver messages? Let's start looking into those details. When we're talking about message routing, you'll also hear the term content-based routing to describe what we're talking about here. What we're going to do here is we're going to instruct BizTalk to extract certain values as it receives a message, and it will include those values in the message context properties that it publishes to the message box, along with the message content. Well, since that information will now exist in the message box, subscribers can now include those properties in their subscriptions. We're going to encounter the term filter expression as we move forward. And a filter expression is a set of logical conditions. And when those are registered in the message box database, they become a subscription. So a filter expression describes a subscription. Well, you can see in this scenario, we have 3 send ports that are waiting for messages. Send port A is specifically looking for messages that have a customer name of Contoso. So we expect that this receive location is going to examine the incoming message, find the customer name, and add that as a message context property for this message. You can see that send port B wants to receive any messages that have a price greater than 1,000. So implied in that is we expect that the receive location will examine the message and find the price and add that to the message context as well. If price is not added to the message context property for whatever reason, send port B will never receive any messages. And then you can see that send port C is watching for messages that have a quantity greater than 500 and a price of less than 1,000. So it's expecting those 2 values to be read from the inbound message body, added to the message context, and if those conditions hold true, send port C will receive a copy. Well, assuming everything is up and running, and all of these subscriptions have been registered, and our receive location is ready to receive messages, if we receive a purchase order from Contoso with a quantity greater than 500 and a price less than 1,000, then we would expect to see that this message is published to the message box, and that the BizTalk messaging engine will deliver a copy of this message to both send port A and send port C. By the way, when I say BizTalk messaging engine, you'll hear that referred to as the messaging runtime or the message agent. And that's the runtime component that interacts with the message box to coordinate all of this activity. Okay, so that message has been delivered. Later on, if this receive location accepts a message that has a price greater than 1,000, but this message is from Fabricam, then that message will be published to the message box. The messaging engine will see that this message matches the subscription for send port B, and it will send a message out. So in short, we're saying that we expect the receive location to examine the message and extract certain values out and publish those as message context properties along with the message. And then we expect each send port to register a subscription that indicates what types of messages it should transmit. We've come across the term port several times already, so it would be a good idea to stop and talk about what these things are. I suppose at a conceptual level, you could say that a BizTalk port is analogous to an airport or a shipping port on the coast, in which goods are offloaded from one type of transportation to another. And you could look at those ports as entry points and exit points for those goods. So BizTalk ports then are simply entry points and exit points that are defined for a particular BizTalk application. Okay, well that's fine, but let's figure out how this more closely relates to BizTalk. Well then, the simplest way to say it would be that a port is a configuration object, the collection of configuration settings that define how BizTalk messages should be received and sent. So a receive port then contains the configuration settings to accept messages and publish those into the message box. And then a send port contains the configuration settings required to take a message from the message box and transmit it. And so BizTalk organizes those settings into collections of receive ports and collections of send ports. Now, amongst those settings is a list of maps. So that incoming message will be compared against a list of maps. And if there is a match, then the message will be passed through that map on the way to the message box. And likewise for send ports. As the send port takes a message from the message box, the first thing that it will do is it will search its list of configured maps. And if it finds a map that corresponds to the type of message it's handling, it will pass the message through that map before it processes it any further. It's very nice that receive ports and send ports can handle more than one map, because we might be accepting sales order messages, for example, and those sales order messages might arrive in one of many different formats. So we can take any particular sales order, pass it through a map, and convert it to a common format before it's published to the message box. That way, that particular receive port is always publishing the same type of message to the message box. And that, by the way, is just one way to use maps in a receive port. You may find that there are other combinations that serve the needs of your application better. And in the same vein, the fact that a send port can handle multiple maps just makes it all the more versatile. In general, we think of a send port as communicating with some particular destination system, whether that's a system within our own enterprise or whether that's a trading partner system. We might even choose the URL that the send port should use at runtime. But in general, we think of the send port as contacting a particular system. A receive port, however, looks at things from a different perspective. We expect a receive port to receive messages that are somehow related, whether they're all coming from some trading partner, or whether they're all of the same type. For example, we might have a receive port dedicated to receiving purchase orders, or the messages might be of different types, but they're all related to the same business process in some way. So if we consider a receive port that is responsible for receiving purchase order messages and mapping all of those purchase orders to a common format and publishing those to the message box, the reality is that those purchase orders might be delivered in many different ways. We might have to read encrypted files from a FTP location. We might need to read compressed files from a file system. We might have to go out to an ERP system and read purchase orders. So this receive port needs to really be flexible. So what BizTalk does is it factors out the details for each of those different methods for receiving a purchase order message, and it encapsulates the details for each of those in a configuration object known as a receive location. A receive port will always have at least one receive location, but it could have more than one. And again, each of those receive locations will contain the configuration settings that are required to accept the purchase order, and each of those receive locations is tied to some URL. I'm going to revisit an animation that you saw in the first module. This animation provides an overview of the path that a message takes as it passes through BizTalk. But this time we're going to look more closely at the receive port and send port. So we have our proverbial purchase order message arriving, whether it's EDI, XML, or flat file. We're going to assume that this message arrives from our trading partner named Contoso, and it arrives in their flat file format. Our application is going to accept that through a receive port, and our receive port, of course, is going to have at least one receive location. The receive location actually contains two components: the receive adapter that knows how to receive a message via some protocol, and a receive pipeline that knows how to convert that message into a format that our application can use. So each receive location that we add to our receive port is going to monitor a specific URL. We might have two different receive locations that are monitoring two different FTP URLs. We might have another receive location that's monitoring a message queue, and so on. The key is that each receive location is monitoring a specific URL. You can say that the identity of a receive location is the URL that it's watching. So assuming we've configured everything correctly, when this message arrives and passes through this receive location, we're going to expect that we have an XML document on the other side. That's not required, by the way. You may have receive locations that just accept binary data and publish that to the message box. But if that's the case, then this next step would not be an option. So we'll assume that once a message has arrived and passed through the receive location, we'll have an XML document on the other side. Now at this point, there's a fair chance that this XML document is not in a format that the rest of our application can use. And so if we have configured a set of maps in this receive port, and one of those maps matches the type of this purchase order, then we can depend on that map to transform the message before it's published into the message box. So by configuring a receive port with multiple receive locations and a collection of maps, we can receive purchase orders from many different locations over many different protocols and in many different formats. And our receive port can take all of those and it can publish all of those various purchase orders into messages of a single consistent format into the message box. So there's a lot that can happen within a receive port. Now, if we have no subscribers to that message, the message will stay there. It'll be suspended. However, in this scenario, we have an orchestration that knows how to process this purchase order. And the orchestration determines that we don't have this particular product in stock, and so we need to place an order with a vendor. And so it publishes a message representing an order to be sent to the vendor. So we have a send port then that is configured to communicate with a specific trading partner, and so it is subscribed to watch for orders to be sent to that partner. When the message engine sees that the orchestration has published one of these orders, it sends a copy of that message to the corresponding send port. Now we can't send out this order directly to our vendor because it's in our own application XML format. And so we can depend on a map, and it will be mapped to an XML document that can be converted to the vendor's flat file format. So when the mapping is complete, the XML document is passed to a send pipeline that knows how to take that XML message and convert it to flat file format. And then it passes that flat file message to the send adapter, and the send adapter takes care of transmitting the message to our vendor. I mentioned that we can use BizTalk to implement something called content-based routing. And that means that we want BizTalk to check certain fields within a message as it arrives, and then route it accordingly. Well, in order to do that, we need BizTalk to extract those values out of the incoming message and add those values to the message context properties. And then once that's done, we can create filter expressions that make use of those properties. So in order to extract a value out of a message and add it to the message context, you need to set up something called property promotion. Every message context property that BizTalk recognizes is defined in a schema somewhere. So to implement property promotion, you need to define a schema with your application's message context properties. And then you need to go into the XML schema for your message and promote the property. So you right-click on any node within your schema, and in the context menu choose Promote, and then Show Promotions. And then you will be presented with a dialog box that allows you to choose the element that you want to promote and the message context property that you want to promote it into. In this series of demos for this module, I will be showing you how to implement content-based routing, and the routing rules are based on two values from a purchase order message. And so in this demo, I will show you how to set up the property promotion. Okay, here we are in Visual Studio. I have the messaging project open, and we're ready to take the first step toward implementing content-based routing. So I'll start by opening the purchase order schema. Okay, one of our routing rules will be based on the state of the customer address. So let's promote that to a property field. So I'll right-click on the state field, and then choose Promote, and then I'll select Quick Promotion. Now, Visual Studio is letting us know that it is going to add a new schema to our project to contain the property fields that we're about to define. It's telling us that it's going to immediately make an update to that schema to add the state property. Okay, so state has been promoted. And you can see in the center pane that a unique ID has been assigned to it in the XML annotations. Now this property1 field is included by default and we don't need that, so I'm going to delete it. Okay, let's save our work here. Now I'm going to go back to the purchase order schema to promote another property that we'll be using. One of our routing rules will be based on the order total field. So let's follow this same set of steps to promote that field as well. All right, well, let's deploy this project so that these schemas will be available to us when we start to implement our routing rules. Okay, the deployment was successful. Once we understand how to set up a receive port, we'll come back and pick up where we left off here. So let's take this from a conceptual level and start implementing content-based routing. I'll walk you through the sequence of steps that are required to implement routing, and then we'll start off by implementing the receive side. So I'll show you how to set up a receive port and a receive location to read in a file from the file system. And then I'll show you how to configure a send port. And then along with that, we will need to create a filter expression. And then I'm going to show you how to create something called a send port group. It's possible to group send ports together, and send port groups essentially allow you to broadcast a message out through multiple send ports. So there are 5 basic steps to implement content-based routing. So you saw me complete the first step already, and that was to promote the fields that we need to use in the filter expressions. You could say that the filter expressions are the routing rules. And so it was important that we promoted those fields to make them available to the BizTalk messaging engine. Once you have the fields promoted and the schema deployed out to the BizTalk runtime, you're ready to set up the receive side of the routing application. So you'll need to create a new receive port, and then within that you'll need to create a new receive location, and then within that you'll need to configure the protocol and pipeline settings. Once you have the receive side set up, then you'll need to configure the send side. So you'll need to create the send ports that will be used to deliver the messages. And if you have a need for any send port groups, you can create those as well. And then as you create each send port, you will need to configure it with a filter expression, which indicates which messages should be transmitted by that send port. Finally, once all of the ports have been created, you will need to start the send ports and enable the receive locations. You can use the administration console to create and manage receive ports and send ports. So it's easy to find the receive ports for an application in the BizTalk administration console. And you create one by simply right-clicking on the receive port node, click New, and then choose a message exchange pattern. So you need to indicate whether your receive port will simply read in a message or whether it will read the message and provide a response. Once you've made that choice, you can provide a name for your receive port, and then you will need to add a receive location. And you can do that by right-clicking on the receive port name and then choosing New and choose Receive Location. And then you'll be presented with a window in which you can configure the details of your new receive location. So in this example, we have a receive location that is going to monitor a file system folder. It's using the file adapter to accept messages. And the receive adapter is going to run within the host named BizTalk Server application. And this receive location is configured with one of the built-in pipelines, in this case, the pass-through receive pipeline, which basically does no processing on the message as it passes through. If you have a situation in which your receive location should only monitor for files during certain hours, perhaps off hours, when you're in the receive location properties window, you will find a schedule page in which you can enter the start and stop time of the service window. Once the configuration settings are complete, you can enable the receive location, at which point it will start actively monitoring the URL that you've provided. And if it finds any messages available, it will attempt to read them in. You'll find a set of properties at the port level that will allow you to configure a collection of maps. And you'll also see some settings that allow you to enable message tracking. If you enable message tracking, BizTalk will retain copies of the message bodies that it processes. Just be aware that the tracking database can grow large if you leave that on. In this demonstration, I'll show you how to use the BizTalk administration console to create a new receive port, and then within that, a new receive location. I'll show you how to configure that receive location, and then I'll also show you how to configure the receive port to process messages with a map. Once that's all complete, I'll show you how to enable the receive location so that it's ready to accept messages. All right, here we are back in the virtual machine. We've really completed all of the work that we need to do in Visual Studio. So we'll be using the BizTalk Administration Console for the rest of the demos in this module. I'm going to begin by creating a receive port in the Demos app. So let's go find that and expand it. Okay, so we can see that this application has no receive port so far. So let's add one. We can right-click, and then I'm going to create a new one-way receive port. Let's name this receive port Purchase Orders. The receive port can't do much on its own, so let's provide a receive location. I'm going to right-click. Let's create a new one-way receive location. This is going to list all of the one-way ports that could contain this receive location. We only have one, so let's select that. Okay, we need to name this receive location. Let's name it after the port, and then let's append the name of the transport to that. Let's call this our Purchase Orders File Receive Location. All right, the next step is to choose the adapter, or the transport for this receive location. Okay, so we have the file transport, and now we need to configure the properties for the file adapter. Let's go find the file folder that we want this receive location to monitor. Under the Messages folder, let's create a new folder and name it In. All right, the file mask looks good. We want BizTalk to pick up XML files from this folder, so let's accept these settings. Now, one last thing that we need to configure is the receive pipeline. The pass-through receive pipeline does not perform property promotion. So we're going to need to select the XML receive pipeline to ensure that those purchase order properties are promoted into the message context. All right, everything looks good here. Okay, so our receive location is complete. Let's enable that. And we'll leave this here and then come back and create some send ports. When you create a new send port, you have the option of either creating a static send port or a dynamic send port. If you create a static send port, you will use the administration console to set the destination URL. If you create a dynamic send port, you won't specify a URL right now. In that case, some component within your BizTalk application will need to provide the URL at runtime. We'll talk more about that further in Module 15. Once you choose the type of send port, then you will be able to configure the specific properties. Of course, you'll need to provide a name and select the adapter that will be used to transmit the message. This particular send port is using the file adapter, and it will be writing messages out to the file system. In this case, the name of the message will simply be the unique identifier that BizTalk assigned when it created this message. This send port will run in the default host. If you anticipate that some particular send port might process a high volume of messages, you might want to configure that send port to run under a different host that's assigned to multiple servers. This send port is configured to use the pass-through transmit pipeline, and that's often sufficient. Even though a send port might be transmitting XML messages, it is not absolutely required that that send port use the XML transmit pipeline. That pipeline implements some very specific features, and if your application doesn't need those features, it's more efficient to use the pass-through transmit pipeline. You can configure a send port to use a secondary protocol if the primary fails. For example, you might have a send port that is configured to send out an email to some SMTP server. Well, if that send port can't establish a connection to the email server, you might want it to drop that message to the file system. As you're configuring your send port properties, you will find an option to configure backup transport properties, and that's where you can provide the settings for your alternate delivery mechanism. You can also configure the number of times that your send port should try to transmit a message, and you can configure the period that it should wait before it attempts a retry. It's also possible to configure a service window, so perhaps your transport should only send messages out between certain hours. You can enter that start and stop time. Since we'll be depending on our send ports to perform content-based routing, we will need to express those routing rules as filter expressions. So we'll need to configure each send port with one or more filter expressions. Filter expressions can be combined with logical and OR operators as well. So each send port will implement a filter expression that describes the types of messages that it should transmit. So an example might be that a send port should only transmit messages that have an amount value greater than 500. And assuming that the receive location has been configured with the correct pipeline to promote that value, then when a message arrives with an amount value greater than 500, the message engine will evaluate that against this send port's filter expression and find a match and send it a copy of the message. So you create a filter expression in the Send Port Properties dialog box by clicking on the Filters page. And within the Filters page, you will see a list of filter expressions. So to add a new filter, you choose from a list of message context properties, and then you select the operator that you need for your filter expression, and then you enter a value that will be used as the basis of the comparison. When you start the send port, that expression will be registered as a subscription with the message engine. And of course, you can add a collection of maps to a send port. You select the outbound maps page of the send port, and then to add a new map, you click on the drop-down list that appears, and you select from the list of maps that are available to your application. If you find that you have more than one send port configured with the same set of filter expressions, you might find it easier to manage those as a send port group. That way you can stop and start the send ports as a whole, and what you'd need to do is use the administration console to create a new send port group, and then you would configure that send port group with the required filter expressions, and then you would need to configure the send port group's list of individual send ports that it should govern. After that, you'll need to go into each of those individual send ports and remove their filter expressions. Otherwise, BizTalk would treat those as two different subscribers, so each of those send ports would be sending out duplicates. One that it would receive because of its own subscription, and then another one via the send port group. Once you have your send ports and send port groups configured, you will need to enlist and then start each of the send ports. When you enlist a send port, you are registering its subscription with the message box. Once a send port is enlisted, the message box will recognize that subscription, so any messages that arrive that match that subscription will be queued up for that send port. Those messages will remain queued until the send port is actually started. And then once the send port is started, the messaging engine will start delivering the queued messages to it. If the send port or send port group remain unenlisted, from the message box's perspective, that send port doesn't exist. You'll find in the administration console that you have the option to enlist a send port and to start a send port. If you have not yet enlisted your send port, but you choose Start, the BizTalk administration console will automatically enlist your send port before it starts. Once your send ports are started and your receive locations are enabled, your BizTalk application is ready to start routing messages. In this demonstration, I'll show you how to create a new send port. I'll show you how to configure it to write messages out to the file system. I'll show you how to enter a filter expression. And then I'll create two new send ports, and I'll show you how to include those in a SendPort group. And then I'll show you how to add a filter expression to a SendPort group. Finally, when that's all done, we'll start up this routing application and I'll show you how it works in the runtime environment. Alright, we have defined our schemas and we have a receive port with receive location. So we're ready to create our send ports. So let's go to the Demos application and create a new send port. So I'm going to create a new one-way send port. And this send port is going to write processed order messages to the file system. So let's name it processed orders file. Now let's select the file transport and then set the properties. Alright, let's create a new folder for the processed order messages. If you look at the file name, it is using a macro that instructs the file send adapter to insert the BizTalk message ID into the output file name. Let's prefix the file name to indicate that it contains an order. Okay, everything looks good. Alright, now we are ready to set up a filter expression. So let's select the Filters page. And now, let's select the message context property for the expression. This send port is going to subscribe to all messages that pass through the purchase order's receive port. So the message context property that we want to use here is known as the BTS receive port name. Okay, there it is. And now we need to enter the value for the comparison. So I'll enter the name of the receive port. And that's it. Now, for any orders that have an address in the state of Washington, we need our application to send a copy of that message to our accounting system, and we also need to send a copy to a sales manager. So I'm going to set up two send ports, one for accounting and one for the sales manager, but they would have the exact same filter expression, so I am going to include those in a send port group. So I'll create the send port for the sales manager next. I'll call this the toManager file send port. And this will be using the file adapter. And I want to write it to the messages out folder and prefix the file name with the words toManager. Okay, we're not going to do any post-processing, so I'll leave the pipeline as is. And I am going to include this send port within a send port group. So I am not going to enter a filter expression on the send port itself. Now I'll repeat those steps to create the accounting send port. This will be the toAccounting file send port. Now that we have those two ports created, we can create the send port group for them. And then I'll right-click to create a new one. All right, I am going to name this group Send for Audit. And now we need to select the send ports that belong to this group. So those will be the Accounting and Manager send ports. And then the last thing to configure is the filter expression. You can see the properties that we promoted in the demo.messaging project, and the one we need here is the state. So we're going to filter on the state of Washington. And that completes the configuration of our send port group. Okay, before we go any further, let's make sure our BizTalk host instance is up and running. All right, here it is. I'm going to right-click and then choose Start. And then the last thing to do is start all of those send ports. And I'll do that in one step by starting the Demos application as a whole. All right, now that everything is up and running, let's send some messages through. We have a set of 4 orders here. Let's take a look at these. All right, we can see that this one should be sent for audit, and so should this one. This one, however, should not, nor should this one. Okay, I'm going to copy all 4 of these to the In folder. We should see all 4 show up in the Processed Orders folder. And then in the Out folder, we expect to see 2 messages sent to our Sales Manager and 2 messages sent to Accounting, representing the orders with Washington addresses. Okay, BizTalk has picked them up. The Processed Orders folder contains the 4 messages as we expected. And then the Out folder contains 2 messages for Accounting and 2 messages for our Sales Manager. So let's look at those and make sure that they all have Washington addresses. All right, there we have it. You've just seen content-based routing in action. Well, now that we've been able to send some message activity through our BizTalk application, one of the nice things about BizTalk is that since every message passes through the message box, it gets a chance to examine it, and it records tracking data about that message. So if we're using BizTalk to deliver messages between various systems and it doesn't seem that the messages are getting through, we can always look at the BizTalk tracking information to figure out where things are going wrong. And so even with the simple application that we've created so far, BizTalk has been collecting tracking data on the messages that have gone through our app. And so we can go take a look and see what's available to us. So we'll be able to find that information in the BizTalk Administration Console, and specifically it has a page dedicated to summarizing all of this tracking data, and that is known as the Group Hub page. If we want more detail, we can always execute a query of our own, and it makes it easy to do that. So let's spend a few minutes taking a look at BizTalk's tracking capabilities. You can access the Group Hub page in the BizTalk Administration Console, and you can find it by looking in the tree view and clicking on the node just beneath the root BizTalk Server Application node. When you click that BizTalk Group node, the center pane will open and display the Group Hub page. And the Group Hub page displays a summary of the current message tracking data. It will show you how many instances of messages are in process. You can also see how many messages or orchestrations have been suspended for a particular application. So the Group Hub page presents tracking data in various summary formats to help you understand the current state of your BizTalk group. One thing to make a note of is that the statistics that the Group Hub page reports do not update automatically. You'll need to press the F5 key to get the latest numbers. Well, the Group Hub does a really nice job of giving you access to all of that summary information about your BizTalk environment. But you'll usually need more detailed information than that. And so you can get access to that detail by clicking on any of the links that you see in the Group Hub page. And that will display a report that shows you the individual items that were included in the summary. You can see, for example, the details of each running service instance. You'll be able to see the name and type of each of those service instances. You'll be able to see the BizTalk application that it belongs to. You'll be able to see the time that the service instance started, and you'll be able to see its current state. If you double-click on any of the service instances listed in the report, you'll be able to see even more detail. And in fact, you'll even be able to see the message or messages that that service instance is processing. Then if you double-click on any of the message instances listed, you'll be able to see all of the details of that message. For example, you'll be able to see all of the message context properties. And assuming that you're looking at data for a live service instance, you'll even be able to see the message body. If you click on the Suspended Service Instances link in the Group Hub page, you'll see a report that lists the individual service instances that remain persisted in the database, but they're no longer being processed. And those particular service instances will remain suspended until someone takes action on them. If you go ahead and right-click on one of those service instances, you will see an option to resume that service instance, and you'll also see another option to terminate it. Of course, you will only be able to resume a suspended service instance if it is actually in the suspended resumable state. But before you go ahead and resume that service instance, you'll want to see what kind of error caused the suspension in the first place. And so again, you can just double-click on the service instance, and that will display the window that provides the additional information about that instance. And then you'll find that there is a tab in that window that displays the error information. So if the instance is a send port, for example, the error information might state that the send port tried contacting the destination system and that communication failed and it exhausted its retry count, and so then it gave up. So if the issue with the communication has been resolved, you can go ahead and resume that send port and it will pick up where it left off. Now if the service instance is in a suspended non-resumable state, you can take a look to see what the error information is. You'll still be able to see the message body, so if you need to save that information, you can get access to it. And then to close out that service instance, you'll need to right-click on it and choose Terminate. So it completely depends on the type of error that determines whether a service instance has been suspended resumable or whether it's been suspended non-resumable. Now regarding the built-in queries, I'm talking about the ones that you can access through the links in the Group Hub page. If it turns out that none of those queries give you the information you need, you can always create a custom query. If you look at the top of the Group Hub page, you'll notice that there is a New Query tab. If you click on that, you can enter your own query criteria. So then you can go ahead and create a query that should return what you're looking for and run it. And hopefully you find what you need. Even with the built-in queries, you can still go and modify that selection criteria to get what you want. You might find, for example, that one of the built-in queries limits the number of records that's displayed. And maybe the service instance that you are looking for wasn't included in the initial report, so you can increase that limit and hopefully find the one that you are looking for. So if you find yourself re-entering the same custom query over and over again, you can just save that query and reuse it. One of the more interesting reports that you can access through the New Query page is the list of current subscriptions. So if you're having trouble figuring out why a new message isn't being routed as you would expect, rather than digging around to find the filter expressions for individual ports, you might find it more convenient to run the query to return all of the current subscriptions, and then you can just double-click on a particular subscription and you'll be able to see the filter expressions for that subscription. So it could be that there's a typo in one of those filter expressions. Once you have a handle on those filter expressions, you'll want to capture one of those messages that's being routed incorrectly, And then you'll want to take a look at its message context properties. And you might find that one of the message context properties hasn't been promoted as you had intended. So, as time goes on, I'm sure you'll find a lot of uses for the Group Hub and Query page as you become more familiar with them. That tracking information will be important to both administrators and operations people, as well as business analysts. And so it's often the case when data is being transferred to a trading partner and there's some sort of communication failure. Of course, it can be a kind of tricky to figure out where the failure is occurring. And this tracking data can help you understand if the transmission to the trading partner is succeeding and maybe there's an issue over at their end, or if you can see that the transmissions are failing, you can get a better understanding of what's going on. Now, the Group Hub and the Query page, by the way, give you access to both live tracking data and historical tracking data. You won't be able to see as much detail when you're looking at the historical data because BizTalk doesn't save the contents of a message once it has finished processing it. If you do need that level of information in your historical tracking data, you can enable an option in your port to instruct BizTalk to save that extra data. Be aware, of course, that your tracking database is going to grow very quickly when you enable that option. To enable that tracking in a port, you need to go out to that port's property page and you'll find a checkbox. And if you check that checkbox, BizTalk will retain the message content for all messages passing through that port. By the way, there are actually two checkboxes. One gives you the option to retain messages before they are processed by the port, and the other one gives you the option to retain the messages after they have been processed by the port. And you can check both of those checkboxes, by the way. And that can be useful if you're trying to figure out why a port isn't producing the type of messages that you expect. It could be that the pipeline in the port has been configured incorrectly, or that a map in the port is not transforming the data correctly. So if you enable those, you probably only want to do that for a very short period of time, just enough time to collect some data that you can use for the diagnosis. And then you'll want to go back as soon as possible and disable those. I mentioned that you can enable tracking in a send or receive port, and that is something you can do at runtime, by the way. That's not something that requires any sort of a restart. Actually, the vast majority of the configuration changes that you make in the administration console don't require any sort of a restart. They're just picked up live. One of the changes that does require you to actually stop something is if you are going to change the filter expression for a send port. In that case, you actually have to unenlist the send port to remove its old subscription. Then you can make the change and then you can start the send port back up. So when we start talking more about orchestrations, I'll show you how you can use an orchestration debugger to see exactly what's happening within an orchestration at runtime. One of the nice things about BizTalk's tracking capabilities is that they're built right into the system. You don't have to do anything to enable it. Of course, as you saw with the ports, there are options to track additional data, but you get the core tracking for free. So you have a couple of lists here that just give you some sense of what BizTalk is collecting. By the way, I've mentioned that you can see the name of a service instance. Each service instance is going to be identified by its class. So when you're looking at service instances, you'll see the names of pipeline classes or orchestration classes, for example. And then also each service instance is identified with a GUID. So the class name then lets you know what type of service instance you're looking at, and the GUID tells you exactly which instance of that class you're viewing. One other option that you have when you drill into the details of a message, you can actually see the sequence of steps that the message followed as it passed through BizTalk. So you'll be able to determine the adapter and receive pipeline that processed the message. If it passed through any orchestrations, you'd be able to see the names of those orchestrations as well. And you'll also be able to see any send ports. You're actually not looking at the details for a single message here, by the way. You're looking at the details for a collection of messages that's known as an interchange. If you look in a message's context properties, you'll find a property named interchange ID. And that identifies the very first message that initiated the process that produced this particular message. So you're kind of looking at a message's ancestry when you look at its message flow. The message might have originated as a sales order message on a receive port, and what you might be looking at is an invoice that was generated further on down the line. But by using this message flow window, you'd be able to trace all the way back to that original sales order message, and you'd be able to determine the sequence that was followed to create this invoice. In this demo, I am going to send a message through our routing application, and then I'm going to go back into the BizTalk administration console and run a query, and then you'll be able to see what the tracking information looks like for that message. All right, let's send one more message through our application, and then we'll go take a look at the tracking information that BizTalk collected. Okay, now we need to go find the BizTalk Group Hub. And then I'd like to run a query to find all tracked service instances. Okay, here we can see some of the historical tracking data. Let's find the tracking information for the message that just went through. All right, these are in reverse chronological order. So the instance of the XML receive pipeline reports when the message arrived, and then the 3 instances of the pass-through transmit pipeline, each of those is reporting a message that was sent. One through the processed orders send port, one through the accounting send port, and one through the manager send port. When I right-click on a service instance, I can get more information about these messages by choosing Message Flow. All right, we can see that a pipeline processed this message. We can see when the pipeline started and completed. And we can see the host in which the pipeline was executing. And we can see that it was an instance of the XML receive pipeline. We can also see that this pipeline was part of a receive location in the purchase orders port. We can also see that this produced 3 instances that were sent out through pass-through transmit pipelines. So let's look at these one at a time. All right, this first one was the manager send port. And then this second one was the processed orders send port. And the third one was the accounting send port. So that's pretty nice. We didn't have to do anything special to get access to that tracking information. BizTalk collected all of that for us automatically. In this lab, you'll have a chance to implement content-based routing. You're going to add a sales order schema to your project, and when you look at the schema, you'll find that a property has been promoted, and the name of the property is order type. So the order type property will contain either the string cash or cred. And so you're going to create 2 send ports. So one send port is going to send out all cash orders, and then the other send port is going to send out all credit orders. And then once you have that all set up, you'll get a chance to test it out in the runtime environment.